In this video, we're going to talk about how to convert equations from standard form to vertex form. So to convert from standard form to vertex form, we're going to take an equation that's written like y equals ax squared plus bx plus c and convert it to y equals a times x minus h squared plus k. So this can be very helpful when we're trying to identify the key features of a parabola from its equation. So for example, the equation y equals 3x squared minus 12x plus 17 can be rewritten as 3 times x minus 2 squared plus 5. And notice that this equation is in vertex form. So what we can do is use a technique called completing the square that you've seen before back in Algebra 1 when you were solving quadratics. It helps us turn a quadratic into a perfect square trinomial. So although you use this to solve quadratics, we can also use it to transform from standard form to vertex form. So to use this method, you're going to start off by subtracting c from both sides of the equation. In this case, c is negative, so I'm going to do the opposite. I'm going to add 7 to both sides. And then you're going to have y plus 7, and then on the right side, I'm going to group that ax squared and bx term. And then from this group, you're going to factor out a if a is not equal to 1. In this case, a is equal to 1, so I can just skip this step for now. And then what we're going to do is we're going to take the value of b, which in this case is 6, divide it by 2, and then square it. So 6 divided by 2 is 3, and 3 squared is 9. So I add that value inside the group. If I add something to one side of my equation, I have to add it to the other side. If I had an a, I would multiply this number by a, but in this case, a is 1, so I'm just going to add 9 to both sides of my equation. So now on the left, I have y plus 7 plus 9, which is y plus 16, and then this is now transformed into a perfect square trinomial. This can be rewritten as x plus b over 2 squared. Well, we know that b over 2 is 3, so this can be rewritten as x plus 3 squared. Now to get this into vertex form, I just need to isolate y, so that's going to involve subtracting 16 from both sides. So we get y equals x plus 3 squared minus 16. So let's try this example. Let's rewrite in vertex form and identify key features. So I'm going to start off by moving that value of c to the other side of this equation. So that means that I'm going to do the opposite of minus 4, and then I'm going to add 4 to both sides. So when I add 4 to both sides, I get y plus 4 equals, and then I'm going to put my x squared plus 2x into a group. And I'm going to leave a little bit of room because I know that I need to add b over 2 squared. So b in this case is 2, so I do 2 divided by 2 and then square it. Well, 2 divided by 2 is 1, so we have 1 squared, which is equal to 1. So now I'm going to go ahead and add 1 to both sides. And when I do that, on the left side, I have y plus 4 plus 1, so that's y plus 5. And that's equal to, well, now I can take this x squared plus 2x plus 1 and write it as x plus b over 2, which is 1, so x plus 1 squared, okay? And if you want to check, you can actually multiply that out. X plus 1 squared does equal x squared plus 2x plus 1. So now all we need to do to get this in vertex form is subtract the 5 from both sides. And when we do that, we get y equals x plus 1 squared minus 5. So that is now our equation in vertex form. So now we can identify key features based on this equation. So since the term being squared is an x term, we know that it's a vertical parabola. Since a is positive, we know that it opens up. The vertex will be at -1, -5. Since it opens up, the vertex will be a minimum value. And we know that the axis of symmetry will be x equals -1, okay? So now let's rewrite this equation in vertex form and identify its key features. So I have x equals y squared minus 8y plus 15. So once again, I'm going to start off by moving the c term. So I'm going to subtract 15 from both sides. So when I subtract 15 from both sides, I get x minus 15 equals y squared minus 8y. So now what we can do is take this value of b, which is -8, divide it by 2, and then square it. So that's going to give us -4 squared, which is equal to 16. So now I can go ahead and add 16 to both sides of this equation. And when I do that, I get x minus 15 plus 16, which is x plus 1. So I have x plus 1 equals, now this is going to be y minus b over 2, so that's y minus 4. So, and that's squared. And now to get x by itself, I'm going to subtract 1 from both sides. And when I do that, I get x equals y minus 4 squared minus 1. Okay, so now this equation is in vertex form. So we can see that the y term is what's being squared. So we know that this is going to be a sideways parabola, right? So since a is positive, it's going to open right. The vertex will be at -1, 4. The axis of symmetry is going to be y equals 4. And so we can identify all these features now from this equation in vertex form. So now you can go ahead and pause the video and try doing this example on your own. So you can see here we started by subtracting 3 from both sides, and then we completed the square by adding 4 to both sides. So that gives us y plus 1 equals x plus 2 squared, and then we subtracted 1 to get this into vertex form, which is y equals x plus 2 squared minus 1. So notice that since a is greater than 0, this is going to open up. The vertex will be at -2, -1, and since it opens up, the vertex will be a minimum. And also, the axis of symmetry will be at x equals -2. So now let's try rewriting this equation in vertex form and identify its key features. Once again, we have an a value. A is not equal to 1, so we're going to use something similar to what we did in the previous problem. Well, as always, our first step is going to be to move c, so I'm going to go ahead and start off with that. So I'm going to start off by subtracting 13 from both sides. And when we do that, we get y minus 13 equals 2x squared plus 8x. So now I really need to use this step 2 because remember it says to factor out a if a is not equal to 1. So what I'm going to do on the right side is I'm going to factor out 2. So that means I'm going to divide both of these terms by 2. So that's going to give me y minus 13 equals 2 times x squared plus 4x. So I'm going to leave myself a little bit of room so I can complete the square. So remember my b is 4, so I do 4 divided by 2 and then square it. 4 divided by 2 is 2, and 2 squared is equal to 4. So on the inside here, I'm going to add 4, but remember technically I didn't just add a 4. I added 4 times 2. It's like, so I really added an 8, right? To balance that out on this right side, I need to add 2 times 4 also. So I now on the left side have y minus 13 plus 2 times 4. Well, that's like y minus 13 plus 8. So that's just going to turn into y minus 5. Okay, so I have y minus 5 equals 2 times x plus 2 squared. And now to balance this out, I'm going to just add 5 to both sides. And when I do that, I get y equals 2 times x plus 2 squared plus 5. Okay, and that's my equation now in vertex form. So since my x term is being squared, I know it's a vertical parabola. A is bigger than 0, so I know that it opens up. Okay, the vertex will be at -2, 5. Since it opens up, the vertex will be a minimum. And I know that the axis of symmetry will be at x equals -2. So now you can go ahead and pause the video and try rewriting this equation in vertex form and then identifying its key features. So here, once again, we have an a that's not equal to 1, but we start off always by moving over c. So we have y minus 8 equals 2x squared minus 4x. And then since a is not equal to 1, we factor out that 2, which gives us 2 times x squared minus 2x. To complete the square, we need to add 1, and then we need to add 2 times 1 over here because that's technically what we added on the right side. So we have y minus 6 equals 2 times x minus 1 squared, and to rearrange this, we need to add 6 to both sides. So that gives us y equals 2 times x minus 1 squared plus 6. Since the x term is being squared, we know that is a vertical parabola. Since a is greater than 0, it opens up. The vertex will be at 1, 6, and since this parabola opens up, the vertex is going to be a minimum. The axis of symmetry will be at x equals 1. So remember, using completing the square, you can convert a quadratic equation from standard form, which is y equals ax squared plus bx plus c, to vertex form, which is y equals a times x minus h squared plus k. This can be helpful when you're trying to identify the key features of a parabola from the equation.